Friends, welcome back to my channel Pharma-info with Shubhashish. The topic today which we are going to deal with is fluoroquinolones. Okay. Now, the objective of this discussion will be first we'll see indications, then moving on to mechanism of action, and finally later on we'll deal with the SAR of fluoroquinolones, right? Okay. Now let us just deal with one after another. Now, so coming to the indication and all, we all know that fluoroquinolones are the antibiotics, right, which are given in so many infections and all. Okay, and the infections, and we know that these are the particular class of drug which has shown or which has been consistently performing in treating infections which are caused by gram-positive as well as gram-negative bacteria, right? Both aerobes as well as anaerobes, right? Both can be treated with fluoroquinolones, right? So long back in the year of 1962, the project was initiated, right? So the first drug came into the existence was found to be nalidixic acid. We'll come to it later on. As I told that first we'll deal with the indications and all, okay? So let us just have a quick look over the indications and all. That means the conditions, the abnormal conditions in which they are being given or they are being recommended with, right? So first, someone has put it very nicely in the form of a mnemonics, right? If we just remember A, B, C, D and E, okay? Almost we are done with the indications, okay, where exactly fluoroquinolones are prescribed, right? Okay, so what is that A? A means anthrax. What is the B? B means bone infection. What is the C? C is cancroid. What is the D? D is diarrhea or some kind of abdominal infections and all, right? And E is for eye infection. Okay, so we are almost done with the indications, but apart from that, some respiratory tract disorders as well as the urinary tract infections, right? Okay, which can also be treated with, or as a first line drug, we are opting nowadays fluoroquinolones, right? Like UTI at the same time, respiratory tract infection, like treating infections which is caused by pneumonia or pneumonia, right? Okay. Now, so these are the indications where exactly fluoroquinolones are prescribed. Moving on to indication to the mechanism, okay, by which they are exerting their action, how they are found to be effective, right, in treating this kind of infections and all, right? Okay. Now, mechanism means basically they are acting, they're targeting what? The bacterial, transcription as well as the DNA formation, right? So basically it is the transcription, right? Transcription and DNA formation, okay? I should say not DNA formation, rather, or in other words, we can say replication, right? So, the fluoroquinolones are basically arresting or acting on these two processes, right? So, they are acting on transcription as well as replication. And what they are doing, they are just arresting the process. And thereby, what happened? Finally, the DNA will not get formed. So, this is how they just arrest what? The DNA formation by acting on transcription as well as replication, okay? If we just go in deep, I should not actually go in much deep, but let us just deal with, because two enzymes which has to be brought, right, while dealing with the mechanism, right? One is found to be topoisomerase 2 and the other one is found to be topoisomerase 4, right? The two can also be called as what? The two can also be called as, the other name of topoisomerase 2 is found to be DNA gyrase. DNA gyrase. It has been found that while acting on gram-negative organism, gram-negative bacteria, fluoroquinolones are basically targeting this one. That is topoisomerase 2 or DNA gyrase. The same thing. They are synonymous, right? But if they are acting on gram-positive one, that time it is the topoisomerase 4 that is being targeted, right? Okay. Basically what happened? There is a complex that is being formed, that is likely to be formed, so that the subsequent event can be executed in a suitable manner. And finally, the bacteria can further grow and grow, right? So that means, in order to grow in a proper manner, in order to multiply in a proper direction, so there should be a formation of a complex. The complex is nothing but either T2 DNA complex or T4 DNA complex. Actually, these fluoroquinolones are stabilizing those complexes and thereby arresting what? Transcription as well as translation. And finally, the DNA formation will get stopped. So, they can act as a bacteriostatic. They can also act as a bactericidal. That means by degrading the DNA, they can act as a bactericidal, and by stopping the mitosis, by arresting the mitosis, they can act as a bacteriostatic. Okay? So this is how they are exerting their action. I think the action is found to be clear. That means in a simple sense, fluoroquinolones are the ones which are acting on both. Few of them are acting on topoisomerase 2, few of them are acting on topoisomerase 4, right? Topoisomerase 2 can also be called as DNA gyrase. Okay, they are basically what? They are basically arresting what or affecting what? Transcription as well as replication, and thereby arresting what? The DNA formation. And with that, they are showing their bactericidal at the same time bacteriostatic effect, right? Okay. Now moving on to the main topic. That means how those fluoroquinolones, okay, were developed and all. Okay. Now that means we have to deal with the ACR. Okay. The final objective, or the prime objective rather, of this discussion. Basically, we'll focus on the ACR. Okay. Okay. Now ACR. So ACR means we have to bring one template, right? Template. As I said at the initial stage that in the year of 1962, the project began. Later on in the year of 1980, one of the drug, which is still there in the market, came into existence. And later on in the year of 1990s, and from 1990 onwards, there are several fluoroquinolones which hit the market. And in the recent past, in the year of 2009, basifloxacin, which is found to be a novel one, right? Novel fluoroquinolones, right? That also came into existence, right? Okay. We'll see later on. But the project was initiated in the year of 1962. That time, it was not fluoroquinolones. Rather, it was naphthyridine. Okay. So what is that naphthyridine all about? That means the one which was obtained, which was invented, which was discovered long back in the year of 1962, that should be considered as a template, right? Because that was found to be the lead compound, and the compound and the name of that compound was found to be nalidixic acid. Nalidixic acid. Okay, as I said that though we are going to deal with the ACR of fluoroquinolones, that means it's a 6-6 system comprised of benzene at the same time pyridine. If we just merge them all together, there is a formation of quinoline. Okay, and if we just put a double bond O somewhere around, so it will become quinolones, right? Exactly where the double bonded O should be placed, that we'll see later on. But for the time being, it was not initiated with the help with the template as fluoroquinolones. Okay, quinolones. Rather, it is naphthyridine. So that time it is the nalidixic acid that poses as a template that poses the template not quinolones, rather naphthyridine. Now what is that naphthyridine? So let us just draw the basic skeleton, right? Let us just draw the basic skeleton. Okay. As we did in earlier videos also, in earlier ACR also. So what should be the basic skeleton? I'll just put here X, right? So now, this is found to be the template structure of what? Fluoroquinolones, right? Now, deliberately I have just put here X. I'm supposed to put here CH because in the subsequent series, okay, there was no naphthyridine as such. Only quinolones, and till now, only quinolones, right? That means a 6-6 system, one is found to be homologous, that is made up of simply hydrocarbon. The other one is found to be hydrocarbon mixed with a nitrogen, a heteroatom, right? Okay. Now let me do one thing. Let us just segregate, or let us just split few areas in the whole template, right? And just see in which respect, in what respect they are found to be important, right? With what respect they are found to be important, right? Okay, that means if we just try to figure out them, that means the basic skeleton, or rather the basic ACR information let us just deal with. So this is found to be the one. So at this moment I'm just trying to split the template into possible zones and all, right? And each zone, they are having their own significance with respect to the evolution of biological activity, right? So this is one of the area. This is another area. This is another area. And this is found to be another area, right? So with that I'm done with what? With that I'm done with the essential requirement. The essential requirement of or the areas which are found to be mostly considered, right, while developing fluoroquinolones and all. Okay. Now we'll see one by one. And as I have just splitted them in 4 different zones and all, let me just deal with them one by one. Okay. Let me just categorize them on the basis of their utility and all, right? So this is the area. You might be seeing that this is the one which is having what? A pyridine. Pyridine with a own as well as a carboxylic group. So can it be called as 3-pyridone? 3-pyridone. So what to observe that this is found to be the pharmacophoric group or pharmacophoric section. That means the one which is responsible for the initial affinity or the interaction. So with this only the initial interaction is being made. So this is found to be the basic pharmacophore of what? Fluoroquinolones. भले ही हम एक 6-6 सिस्टम लेते हैं, लेकिन the maximum activity or the maximum interaction lies within this region only. That means pyridone. That means pyridine 3-carboxylic acid, or rather 3-carboxylic acid pyridone, or pyridone carboxylic acid. Pyridone, this is pyridone carboxylic acid. So this is found to be the pharmacophore. Now coming to this area, this circular portion, right? I have kept it here R1. R1. What for it is here? What for it is here? R1 can be a suitable substituent and all. It can be a suitable substituent and all. So that means probably the R1 means you can just increase the potency level. That means this is the area or this is the zone, right? Modification of that particular zone may lead to a better agent. That means if we just improve or elevate the potency of the particular fluoroquinolone, this is the area which is which is frequently being targeted, right? So this is for the raising of potency. In order to raise the potency level, this is the area which should be targeted, right? Coming to this section, R6, right? What about RC, R6? R6 is, see, basically what we are, in order to improve the pharmacokinetic profile. That means, in order to improve the pharmacokinetic profile, of course dynamic as well. Now, what they observe that, in order to improve the cell wall penetration, this is the area which has to be targeted. In order to improve the cell wall means bacterial cell wall. Until and unless the drug will not penetrate the cell wall of the bacteria, how it will exert its action? The subsequent event has to be executed in a proper manner, no? Then only you can get either bactericidal or bacteriostatic effect. So that means a proper level of penetration should require, right? And in that sense, this is the area which should be altered in such a way so that it can improve the penetration level. So this is for penetration. Now coming to this area, R7. This is the area which is being modified so that the spectrum can be widened. That means this basically governs. This basically governs the spectrum of activity. That means if we just want the fluoroquinolone to be a broad spectrum antibiotic, so that time this is the area which is quite often being targeted. So with that we are done with the 4 different areas, and each area they are found to be significant, right? And they are playing a different roles. It's not that key 4 different areas they are playing a similar role. It's not like that. For each and every area the role has been given, and they have to play in such a way so that we can get an improved version of fluoroquinolones, right? So this is the one which is found to be the basic pharmacophore. That means the one with which, or a set of key features which should be there in a particular chemical skeleton, and which is likely to interact with what it is. This is the skeleton, or these are the features which is likely to interact with the active site residues, so that a significant level of biological response will emerge, right? So this is basically pharmacophore. This is the area which is quite often been targeted or modified for the purpose of raising the potency. This is the area. Coming to this area, this is the area for what? It is just to improve the penetration level. That means in order to increase the cellular penetration, this is the area which requires to be modified. And coming to this section, in order to make the fluoroquinolones a broad spectrum antibiotic, this is the area which has to be modified in such a way so that we can achieve the one which we are after, right? Okay, so with that we are done with the initial things. So this should be there. That means this is found to be the brief essay information of what? Brief essay information of fluoroquinolones. That means what are the prerequisites? What are the essential areas which has to be focused? So that we can develop a better fluoroquinolones, right? Every now and then, right? Okay. So with that we are done with the initial discussion. Okay. So these are the basic requirements. Now I'll move to the next one. Okay. Now let us just go in detail, right? So we are done with the initial things and all. So with those initial things, just keep those things in your mind so that in the subsequent session, okay, it'll feel more comfortable, right, with the discussion and all. Okay. Now let us just put the locant number here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So as I have just written here X, so initially the first point should be, so X can be nitrogen, X can be CH. Most of the times it is found to be not nitrogen, rather CH. If it is found to be CH, then only we can call it as what? Fluoroquinolones. If it is found to be N, then we can call it as 1,8-naphthyridine. 1,8-naphthyridine. And it is the first drug that is nalidixic acid, okay, which was long back in the year of 1962 discovered, right? It was, it possessed 1,8-naphthyridine nucleus in it, right? And it was the drug rather, okay, which is given, because nowadays the use of nalidixic acid is found to be very rare, okay, very rare, and basically it was given to the patient who is suffering from UTI, urinary tract infection, right? Okay, so 1,8-naphthyridine, okay, 1,8-naphthyridine. So that means if X is found to be N, that means it is an exceptional case nowadays, right? But what they observe that the N and CH both are found to be more or less equivalent. That means retention, okay, there should be a retention of activity and all, okay. So with this idea, what they did, they just thought that better, and as it is an example of bioisosteric replacement, so what they thought that let us just target few other points, right? With what? With nitrogen. That means if the CH is replaced with nitrogen, what are the areas? Position 2, position 5, position 6. That means if it is 1,2 nitrogen, it is called sinolones. If it is 1,5 naphthyridines. If it is 1,6 naphthyridines, and 1,8 is already there, right? So in all the cases, there should be, or there is the retention of activity. That means if isosteric modification is done to the ring system, okay, that means CH with nitrogen or something like this, okay, in that case there is a retention of activity. That means antibacterial effect retains the moment you are substituting the ring element with what? A suitable isoster, okay, like nitrogen. Now, so this is the basic thing, the general thing, all right, okay. Now coming to the pattern of substituent here, R1. So what they observe that if R1 is found to be cyclopropyl, ethyl, then anaerobic affinity grows. That means affinity grows towards anaerobic bacteria, right? But if the R1 is found to be cyclobutyl, then gram positive effect raises. So it is the gram positive effect that raises the moment it is substituted with either cyclobutyl or tertiary butyl. Tertiary butyl, right? So that means in addition to the spectrum, obviously the potency level also raises. As I said at the initial level, so this is the area which is quite often being targeted, though apparently it seems that okay, chalo, substitution lead to increase in anaerobic situation, anaerobic affinity or gram positive affinity, but it's not like that. There is an order of this substituents and all, right? Okay, which indicates that yes, potency level also increases, okay, because the similar potency you cannot find in between tertiary butyl and cyclobutyl. There is a difference in the potency level, which indicates that this is the area which is quite often being targeted, not only to raise or not only to widen the spectrum, rather it is also being targeted to raise the potency level, right? Okay, so we are done with this. Now coming to this R2, what they observe that it is the R2 that should not be favorable towards any kind of substitution. They tried with methyl, they tried with hydroxyl as well. So both are not found to be equivalent, right? Both are not found to be equal with their or equireactive, I should say, because methyl is a hydrocarbon, that is hydrophobicity. Hydroxyl is an example of a hydrophilic entity, right? So with those things they just inserted both the things, okay, at a time, one after another, but the outcome was not found to be that much encouraging, right? So that means insertion of a substituent at this position, that means at second position of this quinolones, leads to what? Loss of activity. There is no as such improvement or retention of activity, right? But sometimes it is observed that it is the first nitrogen and the second carbon which has been cyclized. Cyclized means, all I mean to say, the first and the second carbon has been cyclized. What is mean by that? That means if I just try to figure it out, it should be something like this. Okay, like this. That means a 4-membered heterocycle with nitrogen and sulfur. Okay, thiazidine. This is found in one of the fluoroquinolones. Yes, it came, I think, in the year of, rather, in the 21st century only it came, right? It's not that in the 20th century only it was there, right? The name of the drug is found to be prulifloxacin, and it's an example of a broad spectrum antibiotic, right? But when they just did this kind of modification, okay, at this in these two positions, right? Okay, then there was a retention in activity. Not only retention, but also there is an elevation of activity, right? So this was the outcome. This was the outcome of this kind of modification which they received. Okay, in case of prulifloxacin, okay, this was there, right? It is not. It was not failed, rather. Okay. Now, so this is your R1. Now we are done with R2. Now moving ahead from R2 to or C2 to C3. As I said that pyridone carboxylic acid is found to be the pharmacophoric feature to be kept in each and every fluoroquinolones in order to initiate the process. That means the initial interaction has to be made with this pharmacophore. That means pyridone 3-carboxylic acid. Pyridone 3-carboxylic acid, right? It's not that pyridine 3-carboxylic acid. Okay. Now that means the carboxylic group is found to be the one of the prerequisite. As I have just already mentioned that carboxylic group is acting as a pharmacophoric group. That means this is one of the key feature which should be kept in that set of or in that particular molecular skeleton just to initiate the process. Okay. Now the question may raise that can the carboxylic group be substituted with some other or replaced with some other acidic group? Yes, they also did these things. Okay. So carboxylic, what they did basically, the carboxylic was replaced with sulfonic, that means something like SO3H, even phosphonic, sometimes tetrazole as well, right? But all this effort went in vain. Neither sulfonic nor tetrazole was found to be as effective as that of carboxylic group. So that means carboxylic should be there. No other alternative is found to be permissible here. Okay. Now, after replacing carboxylic with the other functional group, okay, they probably, okay, not probably, they did not get any kind of activity. Okay, the activity lost actually. Later on, what they thought, okay, let us just skip this particular carboxylic group, a portion of the carboxylic group. That means they went after what? Derivatization. That means they just made the carboxylic group into its ester. Then also they found there is a complete loss of activity. Okay, that means neither substitution, neither modification, or nor derivatization. Both are found to be not effective in this case, right? Okay. So we are done with this C3 and all. Okay. Now moving to this C4, that is the carbonyl. So as I mentioned that carbonyl is also one of the pharmacophoric features that should be kept in the molecular skeleton. Why? Because the pharmacophoric feature is pyridone 3 carboxylic acid. That means we are still left with what? One, that is C double bond O. And what they observed that C double bond O should be there. They just tried C double bond. They just what they did at the initial level, that they thought that okay, chalo, let us just find some other alternative and all, right? And in that they just tried with sulfonyl. They tried with thioxo as well, but both the things went in vain. That means neither sulfonyl nor thioxo, okay, thioxo has become a suitable substitute for this carbonyl, right? So that means the carbonyl is found to be one of the essential things that should be there in order to increase the affinity, in order to retain the activity rather. So that means in order to initiate the process, the carbonyl should be there. No other alternative is found to be permissible here. So with that we are done with this portion. That means pyridone 3 carboxylic acid. Okay. Now